Hello class, today we'll be learning about aniline. So this is aniline. It is a benzene ring attached to an amine group. And as such, it doesn't have very strong intermolecular forces with itself. It only has lone dispersion forces. But since it has this amine group here, the nitrogen with its lone pair, it could act as a hydrogen bond donor. Since there are so many of these double bonds all throughout the structure, it's both aromatic and resonant, which puts this nitrogen over here in some weird in-between hybridization between sp3 and sp2. Some properties of it, it's very similar to other aromatic amine um, molecules, that it is a liquid at room temperature. It's also slightly basic. It's really easily oxidized since its precursor is the same thing, but with instead of two hydrogens, it's two oxygens. And therefore it can ignite very readily and burns with a pretty smoky flame. Finally, just like other aromatic amine molecules, it smells a lot like rotten fish. So here are all the uses that aniline is used in. Its main usage is as a precursor to a lot of other products, the majority of which is methylene dianiline, which is shown in this reaction here. We have two aniline molecules, interacts with hydrochloric acid, the ketone falls off, and then we're left with methylene dianiline. It's also used in rubber and other herbicides, rubber taking up about 9% of its usage and herbicides taking about 2% of its usage. Other uses are in the creation of synthetic dyes. Originally, when we created indigo, it's been used to dye our jeans. And from there, after seeing how useful it is, in indigo, we created a bunch of other colors. We got purple, we got oranges, we got reds. There's a bunch of synthetic dyes that all use aniline as a precursor. Another usage of aniline is in the medical industry, through azo drugs and their interaction with, azo dyes and their interaction with sulfa drugs. As you read in Napoleon's Buttons, sulfa drugs were pretty big at one point, but obviously they got phased out. Same thing goes with azo dyes. They were very popular at the time, as shown here. This is the azo group, the double bond nitrogens, but also over time, we leaned in favor of more environmentally friendly and human friendly dyes. Finally, I think the most interesting usage of aniline is as a rocket fuel. Aniline, since it's so easily oxidized, it can undergo something called a hypergolic reaction, where it will immediately ignite and react with something right upon contact without needing any other activation energy. So certain oxidizers that are hypergolic with it are nitric acid, sulfuric acid, and some other alcohols. So therefore, I will also show one of these hypergolic reactions. So this is by a dude by the name of Nala Red. He makes pretty cool chemistry videos, and here are some clips of hypergolic reactions. He is using nitric acid with aniline. Okay, that one was pretty good. All right, thank you, class. This was aniline, and this was hypergolic reactions with nitric acid. Thank you so much for watching.